So we've spent some time now talking about theological method, and now we want to move to discussing the relationship between theology and science. So first we'll talk a little bit about the scientific method, and then we'll talk a bit about different ways of thinking about the relationship between theology and science. What we see here is a common way of describing the scientific method, and probably in your high school introductory science class, or maybe if you're looking at this on the web somewhere, you'd find this as a description of the scientific method. And as far as it goes, it is not a bad description. So in this description, we have observation, some observation of the natural world. That observation leads to some kind of hypothesis about the causes and reasons and functions of that observation. The hypothesis is tested through experimentation, and as a result of the testing, a conclusion is reached about the hypothesis, whether the hypothesis is confirmed or not. And then the results are communicated to the scientific community through some kind of publication and dissemination of those results. And then the results are refined. So the scientific community has access to those results. It can attempt to confirm those results, which strengthens the conclusion about the hypothesis, or possibly disconfirm them, or possibly come up with some other pieces or angles or things that the initial hypothesis or observation perhaps didn't account for. And so what we see is that the scientific method, as described here, is an iterative process. And it is an empirical process. It involves observation of the natural world. And it is an empirical process also in that it involves testing. And what is being tested is always subject to some refinement. Now, this is a fairly reasonable description of the scientific method, but there are a few things that we have to observe. The first, of course, is that the natural sciences are, by definition, limited, or at least properly are limited, to the regularities of nature. So it may seem that this scientific method is very objective, and in fact, when we have disputes between theology and science, the dispute is often about, well, science is objective and theology or philosophy is subjective. And perhaps there's some degree of truth to that. On the other hand, notice that already the scientific method is assuming that nature is regular, that there are regularities to nature, that in fact what we are looking at now bears relationship to the way things were in the past, and further that what we're observing now we can extrapolate into the future, at least at the level of some basic laws, some basic functions, some basic regularities. And of course that in itself is really not observable. It's observable in the sense that all of our observations that we have made about nature seem to confirm this. It seems to be the case, as far as we know, that nature is regular. But of course we can't go back, 4 million years and make observations. We can't go into the future 4 million years and make observations. We have a reasonable belief, a very reasonable belief, that in fact there are such regularities. But that belief comes from places beyond the limits of this method. And I think that's an important thing to keep in mind when we're talking about relationship between philosophy and science or theology and science. There are always some metaphysical beliefs, some beliefs about what is and what is possible that are embedded in the method that we're using. The second thing to observe is that each special science has its own procedures, its own limits, and its own norms. Now, what do we mean by that? Well, the special sciences are, we talk about natural science, but we can talk about biology, we can talk about molecular biology, we can talk about genetics, we can talk about physics, we can talk about particle physics, we can talk about quantum physics, and so on and so on. So each of those special sciences broadly is following a method like this, but will have its own ways of doing things and including its own norms of behavior and its own ways of passing along knowledge. And as we get into more abstract areas of what we call natural science, so for example, quantum physics, we're really getting more to a place of mathematical modeling than any kind of direct observation. It's really interesting to me that we've come to understand in recent decades that it must be the case that the universe contains something called dark matter and also something called dark energy. Now, in older natural philosophy, there was some kind of assumption that in the kind of spaces in space, there must be something. It can't be just empty space, and that was called the ether. And the idea of the ether really fell into disrepute and was kind of mocked as a sort of pseudoscience because you can't observe the ether. And now we realize that the mathematical models we have of the universe based on the expansion of the universe and other observations that we have made and mathematical models we've developed from those observations, that there must be a form, or at least scientists believe, there must be a form of matter and energy called dark matter and dark energy that presently we're not able to observe directly. We're not able to observe it directly. We don't know precisely what its properties are. We can't exactly measure it. And yet the hypothesis is that it must exist based on other observations we have been able to make and based on mathematical models. And as you get more abstract into theoretical physics, and if you get into certain aspects of cosmology like string theory, it is really entirely mathematical modeling. And there are some in the scientific community that criticize those hypotheses and those parts of the special sciences as not being really scientific in a sense. But there's always going to be some differences in exactly how the method is applied in each of the special sciences. And then finally, most of the progress in the natural sciences, in the modern natural sciences, is incremental. Revolutions do occur, but they are rare. And so what do we mean by this? So we have a science like, let's say, genetics. Now, the idea of genetics was a revolutionary idea in its time, and the ability to confirm that did significantly change the way that we think of biology. But now we have a science of genetics, and the progress that's being made is based on the model of what genes are and the functions they have and how they are comprised and how they work. Now, I say incremental. I mean, there have been inventions and developments like CRISPR in gene editing, for example, that are in a technological sense rightly described as revolutionary, but nevertheless they're making a move within, an incremental move within the broad paradigm of genetics. But it can be the case that there's an outright revolution, that we come up with a new special science like genetics that really changes how we think about biology as a whole. And yet that's rare. And when revolutions occur, usually they don't completely dispose of the previous special science, but they usually build on it or modify it or enhance it, sometimes in surprising ways. And a good way to think about this is between classical physics and quantum physics. So in the Newtonian era, and we'll talk more about the Newtonian era and the history of all this next week, but in the Newtonian era, you have a model of classical physics that suggests that the universe ultimately at the physical level is mechanistic, that you could, at least theoretically, if you knew all the variables, predict events based on the properties of motion within all of those variables. But then in the early 20th century, you begin to have the development of quantum theory. And with Einstein's theory of relativity and the development of quantum theory, you really have a revolution in understanding that, in fact, at an even more basic layer than quantum physics, than classical physics, the universe is actually probabilistic. It is not deterministic. And the laws, so to speak, are probabilistic laws. Now, that doesn't do away with classical physics. At the level of our ordinary experience and observation, classical physics still obtains. We build and fly airplanes based on the understanding of the rules of classical physics. But we also understand that beneath that, there's a deeper layer of quantum physics. So it is a revolution, but it doesn't entirely discard the prior special science. So that's just a bit about the scientific method. I also want to make a note about the philosophy of science. Because as we're talking about the relationship between theology and science, we are also, in a sense, talking about the relationship between philosophy and science. And most scientists who are working in the lab are working pragmatically. There is a problem in front of them, a hypothesis in front of them that they want to confirm or disconfirm, or an engineering problem that they want to solve. And they are operating relating to that problem and not on kind of bigger philosophical questions of meaning or of the nature of things in general. Philosophers of science, on the other hand, debate the nature and possibility of scientific knowledge at all, debate realism versus non-realism. Is the universe we're observing actually, in a philosophical sense, real or not? The possibility of non-material entities. So is mind, for example, a kind of non-material entity, or is it entirely material? And other big, long-standing philosophical questions that really are questions that philosophy has debated for thousands of years and that are intensified or modified in different ways by our understanding of the natural sciences. Now, the scientist working in the lab isn't debating all these things. Scientists working in the lab may assume realism or may just simply set those kinds of questions aside. Partly because of this difference in the nature of the work, the relationship between working natural sciences and philosophers of science can be just as fraught as the relationship between theology and science. Many working scientists might think that the philosophy of science is just sort of a bunch of woo-woo kind of irrelevant discussion. And some positivist popular writers about theology and science assume that stance as well in many ways, even though they are in fact doing philosophy of science. And as we get into this over the next few weeks, what I'm going to suggest is that some of those kind of conflict models from the side of some of the new atheists, for example, really are assuming a kind of positivist philosophy of science that almost no philosopher of science would assume today. And for me, it's actually one of the interesting and kind of frustrating things about this whole discussion. But nevertheless, just realize that there are big questions and fraught questions that arise in that domain as well.